Good evening, all. Today we have with us alumnus architect Arjun Mande of 96 batch as our eighth and last speaker of this webinar series. Good evening, Arjun, and welcome to the international webinar by alumni of MMCOA, 8 days, 8 alumni, and 8 countries. In spite of busy schedules, varying time zones, and other logistical challenges, Arjun graciously accepted our invitation to become a part of this first intercontinental webinar series. Thank you and welcome again. After completing Bachelor's of Architecture from MMCOA in 1996, Arjun pursued Masters in Urban Design from SET University in 98, and then Masters of Architecture from Washington University, USA in the year 2000. Since then, he is working extensively in the field of urban design and urban planning, currently working as design principal at Goody Clancy in Boston. A firm grounding in environment-sensitive architecture and urban design gained while traversing 2 subcontinents has to a large extent shaped his sensibility towards cities and buildings. The traditional practice of architecture still looks at iconic to be the answer with environmental responsiveness, flexibility of use and resiliency only applied after the fact. Arjun sees architecture as design of spaces and memories, which are unique to the individual's experience. These memories can become richer with layers of change that a building undergoes over time. Looking back over the past two decades, Arjun has traced a common theme of striving to design built environments that are memorable, innovative, in unison with landscape, environmentally sensitive, and most importantly, adapt over time while creating memories. Welcome again to this webinar series, Arjun. Over to you.
Thank you. I'm really honored, and can you guys hear me okay?
Yes, we can.
Excellent. I'm going to share my screen. I'm really honored to be invited here to present my work. There have been some absolutely fantastic presentations, and I hope I'm able to contribute something to this wonderful series that's here. So I'm going to share my screen. Excuse me. Can you guys see my screen?
Yes.
Excellent. Chaos and order and chaos, however you want to read it. The word chaos has always fascinated me, and so has order, and one follows the other, and no matter what, it's a repetitive pattern, and there's a reason why I call this presentation that, and I hope that gets clearer as you see the slides. I'm hoping to finish up the presentation in the next 50 minutes or so, and then we can have a conversation. I think that's the most fun part. Next slide. So as was just mentioned, I am in Boston currently, and I work for a firm named Goody Clancy. I'm one of the partners there. It's a 70 person firm. Most of our work is higher education. That's pretty much all we do. Our work is limited to the East Coast, up and down the entire East Coast of the US. Arti just mentioned about my urban design and architecture experience. I think it was really important for me to do urban design and just to understand how buildings kind of fit in the overall environment. I think buildings are living organisms, and they don't. A role of an architect does not end at the wall, at the outside wall. I think it goes beyond. They're connected to everything. They are like octopuses. with these tentacles that connects to cities and our lives. So that urban design degree was really important. But after doing that, I realized I was in more love with architecture more than urban design. So I kind of did my master's there, and I came back, and most of my work is in urban design. But I did try an urban design stint somewhere, and you'll see that. Uh, Americans are one thing that I've learned there is Americans love to take a pause and discuss, and it was really annoying at first, and I understand why they do that. Taking a pause is not considered smart in India, and I don't know why. And maybe this is our generation. I think the previous generations definitely did take a pause, like our grandparents and maybe even our parents. But that taking a pause is extremely important in whatever you are doing in life, and that's it's not limited to architecture. And taking that pause makes you think of three different things mostly, and it all comes to how, what, and why. Why you are doing what you are doing, what you are doing it for, and how are you going to do it. I think those three words can be applied to anything that you are doing. You're buying a new car, you're getting married, you're doing architecture, you're designing a new building, you're ordering Uttappa and Vaishali, it doesn't matter. Take that pause. And I think it is never too late to ask these three words to yourself and ponder. I think it's extremely essential. I did it very late in my life. Hopefully, and I'm talking to students here right now, hopefully you will do it sooner than I did. I am the third generation architect in my family. So we've been poor for three generations. These are some of my dad's sketches. I've always been hanging around people who are into arts and music. So it was kind of part of me growing up. And again, I took that pause recently in my life just to understand how did it began for me? What did something click back, 20 years back, 30 years back that told me to become an architect? I don't think it did, but I was really fascinated by buildings and by landscape. And I remember my father is originally from Dhar, and there's a place called Mandu close to it, and we used to go there quite often. Basically, every time we went to Dhar, we went to Mandu. And these are these abandoned ruins there. And but my dad would talk about proportions and scale and landscape, and it was so beautiful. And these are not my pictures. I got them off the web, but this one particular picture was kind of really always haunts me. These are horse stables on the lowest level of the fort, and the arches and the views and the vistas and the materiality and structure, color, proportion, everything was just so perfect there. And if you would look left, you would see these beautiful mountains and green landscape. And that always stayed with me. My dad's uncle was chief architect at Chandigarh. He worked with Le Corbusier when Chandigarh was being made. My grandfather was the head of Haryana Urban Development Authority. So I used to go to Chandigarh every summer, and I used to bicycle from his house to a roller skating rink, and I would pass this. And it used to be hot, but when you came closer to this water body, it used to cool down. And this memory is also kind of just etched in my brain. And this was such a unique place, and it was such a beautiful city, so grand from everything else that I was used for. So again, you're coming back to chaos and order. So what is chaos? Chaos is complete disorder and confusion. It's like when you start a design, complete disorder and confusion. You start anything new in your life, there is that complete disorder and confusion. And chaos is also a behavior, unpredictable and absolutely random. And there is something called as chaos theory. I'm sure you guys know about it, where they say when a butterfly flaps a wing 1,000 miles away, it becomes a hurricane and a tornado, a month after. So basically, a small event in your life today might totally, inconsequential small event might totally change the trajectory of your life 15 years down the line, and 20 years or 20 years down, you might say, oh, you know what? That one conversation I had with that person totally changed how I do things. And it's something really fascinating about that. This is total chaos. This is old Delhi. I mean, but I can see order in it. There is a very clear, and there are places like this in Pune, in every city in Bombay. You go to any city in India or in Asia, there are places like this where there is order, where you can find order in this chaos when you are there and when you are in that space. And of course, New Delhi, it's the new chaos. It's equally bad. It's there is traffic and there is congestion and there's everything else. But it seems orderly, but it really is not. I think places that you visit definitely dictate how you design and how you think. I think these are some of my favorite places that I visited over in India. And I see these pictures over and over again just to remind myself of the scale and of the proportions. Colors are so amazing in India. I really miss colors. Whenever I come here, it's like you open your eyes and there are like a blast of colors, and that is really amazing. Charles Korea, I was always inspired by him. I've stared at that Kanchenjunga section for, I don't know, hours together. His work is beautiful. You can see all those colors there on your left, how the materials come together. It's just fantastic. I love his work. And he was more of an intuitive architect. And I also do things by intuition, and kind of I try to see his books and learn from what and how he used to do things. I don't know, some of my classmates, Amit, Vinod, Satyajit, Asmita might remember this. This is Jeffrey Bawa. We found this book in our library, and all the things that we talk about today, beautiful details, being one with nature, biophilia. I mean, he was doing this like 40, 50 years back, and these are some of his examples. And this was really inspiring at that time. So I think architecture definitely is a physical manifestation of your experiences in life. There is no, I mean, that's my belief, and you might agree or disagree with that. Every architect has a process. I have a process, which I'm sure is different from yours, but ask yourself what that process is that leads you to the final design. Sometimes in school, we are not taught to give an order to our thinking. It's all very chaotic. So try to get an order, because once you find that order, it's not that you've found it, you're going to be refining it basically over and over and over again. It'll keep evolving. It'll keep evolving. Nothing is constant. I made a list of words for myself that I felt what drive me, and I did this. I delete words from it. I add more words to it. Some of them I think make sense. Some of them I think maybe don't anymore. But I think the buildings definitely have to be evocative. They have to tick something in you when you see there. There has to be a sense of, oh wow, this is beautiful. I wish I work here. I wish I lived here. I wish I studied here. Something like that. They should be expressive of what form follows function, function follows form, the usual question that we have all asked ourselves. It should be simple. Doing simple is more difficult than doing complex. I think making buildings beautiful and simple is more difficult. And I think simplicity is extremely important. Buildings should be part of the whole, and they should belong. They should be part of wherever they are, city, neighborhood, district, whatever. Adapt proportion and scale. I love proportion. I think proportional scale is one of the most important things which we don't talk about more in school. We only talk about cool facades and cool views and 3D renderings now. We don't talk about proportions and scale, and that's extremely important. And I think I'll jump to the last one, climatically responsive. I think that's really, really important in the times that we live in. If I do this list all over again, climatically responsive would be my first one, right after proportion and scale. I made this statement for myself. I'll be lying. Everything has been done before. I'll be lying that I'm the only one who came up with this. No, there is nothing unique about this. I'm sure thousands of architects have thought and written about this. So, well, to me, the role of an architect is to come up with a singular vision. And this is really important when you work in a larger firm. with a large group of people on large projects, it gets more and more difficult to have that singular vision. I think spaces should be memorable, innovative, in unison with the landscape, definitely, and environmentally sensitive. But to create a singular project vision, I think, is the most important role for an architect. I love to sketch. That's how I think. Everybody does things differently. I'm fascinated by facades. I love fabrication. I love how to modularize facades, and I think them through as I'm drawing. I love doing landscape and integrating the buildings with the landscape. I don't want my projects to end at the doorstep of the entry lobby. I want them to extend beyond, both inside and outside. Again, nothing new, nothing profound. But I think sketching helps me think about spaces, think about how I can layer things inside the project, how I can lay the programs in. Sometimes doing very simple diagrams can help. And these simple moments help you define what the project can be. For example, that can lead to something like that. Doing simple massing diagrams as to not just thinking about the building, but everything around it are also very important. How, when you design a building, because I do most of my projects are on campuses, so how can one building not only benefit itself, but benefit all the surrounding buildings? I think we are always talking about that in a campus setting. Sometimes the building have to be special and have to stand out. And again, if that's what the program requires, absolutely, one should do that. One should never shy away from doing that. Sections are a fun way to understand them. Again, I'm sure you guys know that. But thinking about the section, the program, the landscape, all at once, and how it all works together, I think I love thinking through that chaotic process and find my order in it. And I really enjoy that process. Sometimes we forget how the building might look like, not only from the end of the site, but also 5 blocks, 6 blocks, 10 blocks away. And that's critical. Important to think about how people move through spaces, move through buildings. What would you see from the first floor, second floor, third floor, from the landscape, from inside out, outside in? All of those are really, really important and should be thought through. Inside spaces, making interesting inside spaces. For example, we had this client here who did not like underside of stairs. And so we came up with an idea where there could be some kind of a program under the steps. And this is the image on the left is not my project. Should be very clear about that. But I love that idea, and we did something similar for it. So I'm going to share with you 4 of my projects. I don't love those projects, but I've learned something in that process. So I'm going to share what I learned there. Like I said, most of my projects are on higher education campuses, mostly universities. They vary from a lab research building to an admission center to a dormitory classroom building, business schools, science complexes. Now everything is basically all getting amalgamated, where you have classrooms and academic program right on the first and the second floor, with residential on the upper floor. So I have done pretty much every building type that's there, but I enjoy doing lab buildings the most. There is something really fun about buildings like that. Most of my projects generally are in the 80 to 100 million range. Takes about 2.5 to 3 years to complete. The teams are in-house. Our team, without all the consultants, our design team is about 8 to 10 people, and there is generally a principal, a managing principal who manages, a design principal, that is my role, and then there's a project manager and a project architect, and then there are more people. So that's kind of the role and the way our office is laid out. I think that works well for us, but I know every firm thinks differently. So I graduated in 2000, as Arti mentioned, and my first project actually was with Charles Correa. He at that time was I should step back. Our office does a lot of projects at MIT, and Charles was teaching at that time, and it took me a while to call him Charles because I used to call him Charles Sir in the meetings, and he would get annoyed, like, why are you calling me Sir here? So finally, it took me a while, and I started to call him Charles, and I'm calling him Charles. Maybe I should call him Charles Sir here. But it was really it was joint collaboration. It was a really big project on MIT's campus, right opposite Frank Gehry's building, which was essentially on this side. The building was sitting on top of railway tracks. It was a 7-story building. There were 3 big donor families. So there were 3 different blocks to it. And so you come up over the tracks, and there was a big atrium, which was this floor plan. And it was a building for brain and cognitive research. It was a combination of wet research lab, and dry research labs. By dry labs, I mean more computational labs. And it was a really fun project to work with. We talk about form follows function and function follows form. In this case, it definitely was form follows function. Actually, I'm joking. It was function follows form. Charles definitely wanted what he wanted on the outside, and it was clear that the building definition, the outside, was going to be defined by him, and all the interior workings of the labs and everything basically was going to be Goody Clancy. And that's essentially what happened. It's come up as a beautiful project. It's been there now for about 15 so years, and it still looks amazing. The interior space had this wonderful atrium space, and with all these levels that Charles always does. But what was most interesting part about this and the learning experience was, is there a way to merge Charles Correa's Southeast Asian design philosophy to a New England cold weather? Is there a way to do that? Should you do that? Should you not do that? If it's a Charles Correa building, should it look like a Charles Correa building no matter what it is, where it is? And that's a question. I don't have answers, but that's a very important question to ask. That should a building in Delhi look the same as building in Boston? Should it look the same as Florida or in Pune or in Kerala or wherever? Like, does the building surrender to the local vernaculars? What do you learn from the local building style, building industry? Do you apply to it? Maybe you do, maybe you don't, but that's a question that you guys have to answer for yourself. The most fun part of the building was this really cool glass skylight, which was being held by these tension rods, and these rods. These appeared to be cables, but they were not. They were essentially stainless steel rods, and it was this beautiful skylight that got tons of light into the atrium space. Right after this, I got really interested to integrated design. It's because, especially that the buildings that we're doing now, it is not only the architects who contribute. There is a landscape architect, there is a mechanical engineer, structural engineer, and we are all working together in this integrated design approach. And it's difficult because everybody wants to have a role. And that's where the architect's job is to come up with the vision, really becomes important. In the US, there is the Council of Architecture here, there is AIA, and they have a certain design excellence parameters that they have come up with very recently. And it's basically the ring that you see on the left, which is this one. And then Living Building Challenge, which basically there are 9 petals in it, and they push you to have net zero energy, net zero use of water. Basically, you're producing energy in the building, harvesting water, healthy materials on the inside that don't off gas. Like when you buy a new car, that wonderful new car smell, well, it's not that great for you. So getting rid of that smell is really, really important. So for the new carpet, for new fabric, something like that. And then there is the Wells International Wells Building Institute. So that's even more tougher to get than Living Building. For Living Building Challenge, it's an interesting website. I hope you visit the website. There are 9 petals, and it helps you organize your projects. And of course, USGBC, which is LEED. And I know there's an equivalent of that here in the US. I briefly worked for a bridge design firm. I did a competition with this person by the name of Miguel Rosales in New York. We won the competition. It didn't go anywhere. But doing bridges, it was basically trying to my urban design itch. I got rid of that. They're really fun elements. Interesting to work on, but I think my love was more with architecture, so I kind of came back. This project is under construction. This is at Dartmouth College. It's called the Irving Institute. Irving is a big oil company. They have started an institute for energy and society in which they research different energies that can be developed and for the benefit of the society globally. The building sits. How are you doing on time? The building sits on this mall, so something called as Baker Library, which is the heart of the Dartmouth campus, and there is this long mall there, and so our project site was here. This part of the project is called the West End. It's where the Tuck School of Business and School of Engineering is in this zone. So it was a really important site for them. So it was a very traditional campus. So they wanted a traditional looking building. So even though our building looks traditional, all the detailing is extremely contemporary, and we were able to convince them of that. But the idea was that the building becomes an anchor to that end of that mall, and it actually sits on top of an existing building, and how that integrates and makes spaces both inside and outside with a large green space in the front. Showcasing high performance for a building was extremely important here in this case. We did and this is a very good example for integrated design approach, where the client was extremely willing and wanting to make that additional commitment to pay the premium for having a building that is high performing. So we did carbon analysis, life cycle analysis for everything and anything that we were doing. Every elevation of the building has a different glass type. The ratio of wall to glass is different depending on what orientation it was on. The R value, the U value for the roof are different. The type of glazing frames that we are using are different. This is a northern climate, so it's like really cold there. But we wanted to experiment and see if we can get rid of air conditioning totally in the building, because in the summer months it does get hot. So that meant pushing the building to conserve as much energy as possible, which means getting the window to wall ratio down so that the building doesn't absorb that much of heat. So we did an entire analysis and worked with our building scientists to figure out what worked best for what elevation. Lot of analysis and work done to figure out what is the right number, how much shading each of the facade getting, because there were a lot of existing buildings around it. So, and then we kind of made our energy performance chart for ourselves. Now, this is the base case scenario, and what happens if you have an improved envelope, which is a high performing envelope, or the facade all around, you come down by a bit. What happens if you improve the lighting and the mechanical systems, you come down by a bit. What if you do some advanced measures like automatic exterior shades, automatic window operable? So that's all computer connected to building management software that controls all that. And then and then maybe even produce energy itself on the building. So that was our goal. So we set that up very early in the building process. And that's all we were able to achieve. We were able to, There was a big retention tank down in the green here. We were getting all that water, storing it there and reusing it. There are solar panels up on the roof that generate electricity. There is a natural ventilation system in the building. All the windows open and close by itself. There are automated shades that come down. There's a double skin facade up in front, which actually acts as a chimney and sucks out air on the front on this side, and then the atrium does the same on the other side. So it is a pretty large building with intense program, but the overall energy used for the building is extremely low. And working together in that group, that's was the biggest learning moment for me, that it was essential that we bring the team together and work as one. Getting into a little bit more detail, so like if that's the proportion you want on the outside, what is the thickness of the wall, the materiality, so we kind of quickly worked on the details here. And what is the window to wall ratio there? What is the curtain wall ratio? How much of that, how much for the double skin, what is the dimension that's actually needed? And then we kind of worked on the elevation, and that's how, if you combine all that together, how would that look? So that would look something like that, right? And then testing is really important. And maybe it is done here, where you actually make a small mock-up. We actually make a small room with the windows that we are going to use. And then they have this large fan on the crane with water, and they splash water on the building to test if any water is getting into the building. Is the membrane acting well? Is the insulation acting well? And all those things. So that's really important part of the process. And it also helps people understand how all the materials come together. And of course, the other mock-up, all the colors. We have wood windows inside. So even the mullions are made of wood. That was really good. So this is under construction right now, and it kind of looks something like this right now. There will be automated shades here, which are not currently installed. Parts of the window open automatically when the weather is nice outside and the air conditioning shuts down inside, and it pulls kind of fresh air in. So it's all a very integrated system, and that's how it kind of works. Where the glass volume in the front and the atrium inside kind of act as these reservoirs of air, and they supply the air to the program spaces as and when required. There's a large skylight here, and we wanted to make sure that the right amount of light also gets in, because the more roof we have, the more photovoltaic cells we could have on our on the roof. And we did not have a program, so we were working with the program with the institute itself, and that was really, really fun. Of course, furniture selection, fabric selection, this was really important to the donors, so that was happening on the side. And these are some of the renderings of what the spaces might look like. That's an electronics lab without the equipment, of course. That's the entry to the building. So you're kind of coming from the left, going in. There's a small cafe. Fireplaces are really, really important. They give you warmth, and they're like a community space in a cold climate. So we had a gas fireplace here. It's totally opposite of what you should do in a high performance energy building, but this is one time where we had to surrender and give in. And so then this video kind of shows you the types of analysis that we did for the skylight that I just mentioned. So this is on the summer, or one of the summer days, longest days, and just to understand how the light would travel from 5 a.m. in the morning till 9 o'clock at night, and what is the path of light and how much illumination you get. And so we kind of did that analysis for the longest day, the shortest day in the winter, summer. And that was extremely helpful for us to understand. So that's the atrium space. That's what we are calling it, the community living room. It's going to be this wonderful, exciting space. Those grills that you see, the wood grills that you see, are the places where the water gets absorbed. The air gets absorbed. So this is the air reservoir that's here. So this is under construction. It's supposed to be done basically in the next 3 months. This is where we are right now. That's the curved bench. Those are you can see there are mechanical diffusers right there at the back. That's that wood stair, a wood gathering stair here, and the curtain wall is already up. Um, this was an interesting project. This was a dining facility, classroom spaces, offices on on the first two floors, with a large residential component on the upper floors. And there were about 620 beds. So we wanted to make sure that the building does not look like this ginormous block that takes over everything. So we kind of decided to divide into three different parts, three different blocks with a horizontal podium, which had all the common spaces or the campus amenities that were going to be used by everyone. Um, I love doing these diagrams. These are analytical diagrams just to understand how the program is distributed. So very active floor, first floor and the second floor, and then the residential program that happens on the upper floor. Um, and then we kind of track the movement of pedestrian traffic. We want this courtyard in the middle, or not, it's not an enclosed space, but this green space in the middle was going to be a multi-purpose functional space where there could be concerts, a fair, you know, a green place to hang out for students. It had to be a lot of things. So we calculated, the red lines are basically the amount of pedestrians that were walking and where they were walking to. So we kind of did an analysis to scale our green spaces there. Sometimes it is difficult to figure out, and I was not happy at all with how that corner, I struggled with the corner so much, that corner, and we did so many options, but nothing worked out the way we wanted. In the end, we landed up with this, and this is one of those things where it's a learning moment that, you know, wish this brick volume was coming all the way down and wish this corner was more resolved. And we definitely needed more work here. And that's a lesson learned, at least on this project. So the large green space, the idea was a very visible first and the second floor with that inside-outside connection, and then the upper floors are residential. Here also we studied the envelope very carefully. All the window surrounds that you see are shaped accordingly, according to the orientation, so they only let so much sun in on the facade. So this is one of the blocks that you see here with, like I said, a very visible and open first and the second floor. The dining had this beautiful views and was visible from their football field. So we wanted to have some interesting roof profile. So we kind of came up with the faceted facade. Even though the lengths vary, we wanted to modularize this. I love modularization where you can get multiple elements out of one and then you combine them and it makes this beautiful pattern. So we did that here. So each of those angles are very similar. And then we modularized one of the facade faces and then we combine them differently. And that's fair. From the football field, you know, that building is extremely visible, the first and second floor, and you can see that ceiling there. So generally a residential hall has a common space. So each of these residential halls were associated, or the floors were associated with a common space on the upper level. I love juxtaposition of curtain wall and punched openings and materiality and how that comes together. I love to zigzag and jog them to be more expressive. So you're kind of getting more by doing less. And you're doing it at places only where it's required. So for example, here, you really did not need any glazing here. So we kind of got that down and then we turned it around and then got it down because that was an entry. And it all worked out, I think, really well. I love sharp corners. Generally, most of my projects do have a sharp corner. I don't know why, they just fascinate me. It makes the building really very evocative. And there is no rhyme or reason to that. That's the only reason I have. This was a very interesting project. This was a 1953 international style building. And we were told to blow it away and make a new building there, but we just fell in love with the building. And the big idea here was we did an addition to it to make it really active and open. And we kind of this is an admission center for Boston University, and it's the building, existing building on the first floor has not that many windows. So the idea here was to open it up on the first floor, and because it was at an angle from the street, we wanted the canopy to stick out so that generally people who come to an admission center are coming there for the first time. So we wanted it to be very noticeable from outside. So we pulled that canopy out, and Boston University's color is red. So hence the red color. Also, they wanted a sequence of how students and parents travel through the building and out. So there is generally something called as a student ambassador that has a group of 20 people, like maybe 10 students and 10 parents. And then they make you walk through the building, show you a presentation, and then you kind of meander through the building, come out, gather again, and then go see other parts of the campus. It's a very American thing to do. So that was the sequence we had to design for. So we had an entire landscape element here, which we kind of integrated with the design. The diagram on the right kind of shows all the additions that we did. So, like for example, we opened up that window, all the windows there, make that large addition here on the front, a large addition on the back, and of course, up the building systems on the top. And that red color was essentially just on one wall that was kind of coming down and connecting all those spaces like a connective tissue. So this is, excuse me, this is an existing picture. So that's how the building was. So if you see here how the building kinks back in, so that red canopy kind of really sticks out, and you can see, well, if you have to tell somebody directions, you can say it's the building with the red canopy. And so here you can see how we opened up that building. We called it BU on stage, where we're keeping all the activities that Boston University is proud to display on stage there, so that people who are coming there for the first time could see it. So you can see that red color there, and it travels up. This really inviting canopy, that red material that goes and comes down, and then there's a large digital screen there. And this used to look like something like this on the left-hand side. We opened up on the inside and added this large glass volume. Luckily, it was on the north side, so not a lot of energy use, so that was great. So this is how this image on the left here kind of shows you how it was. And now it's opened up, and you were always visually connected to the outside. That was part of the design concept. I love how materials come together, like for example, stone, metal, glass, metal behind it, stone again here. Like the composition of that is so important in a building. And if you don't have that right, and if you don't have the colors right, a very beautiful design could totally go in a different direction. So that's how it kind of looks like from the river side. So there's a river, Charles River, or one of the rivers in Boston is just on this side. And it's extremely visible and luckily does all the things that we wanted it to do. This is the last project. This was a very fun project. This was also a large addition to a laboratory building in upstate New York. There's an architect by the name of Botany Seagull. He's based out of New York. They did the original building, and we were adding a building right next to it, actually touching it. And it was a very complex site with the building sloping from 0 to 30 feet on one side and 0 on the other side. And the overall dimension of the site was about 300 feet. So it was a very long facade. And they wanted the vision that the president of the university had, was that it had to be something very evocative that would help them recruit new faculty to the campus. So the building above the red line was the existing, the building below it was the new. So the idea that we had here was something we call 1+1 = 1, where the building, even after the addition, behaves as if it's one building, even though they're two buildings. And the big idea here was to have a zipper or an atrium space, which we call the zipper. Imagine a zipper of a jacket kind of binding two of those seams together. And that we introduced a skylight there for the entire 300 feet of length. And there was tons of light that was coming in from there. And I think that was one of the most important features of the project. We did an intense analysis of the program. So the first floor was parking. We made use of that site that was dropping down 30 feet. So there was 30 feet here, 0 here, and then an animal floor, and then 2 lab floors. And there were multiple components to it. The biggest challenging piece was that it had to be flexible. That means that if there's a researcher who's doing research here today, might not want any of these these are called lab benches. They might not want any of these so that they could set up a large experiment there. So this had to be flexible and be taken out. And because multiple researchers work together on a project, there had to be that transparency between large program spaces. So hence this idea of providing good amount of glazing between program spaces that could connect. And so you can see here, everything is movable here. So you could basically move this entire piece of laboratory bench by disconnecting the mechanical systems here, which is air, vacuum, gas, like in a hospital, and then electrical and some other gases. So we could kind of take that out. And so the building systems were designed that you could do that. And it would be accommodated in the overall flexibility of the building. There's a person by the name of David Carpenter who, if you Google, he does very interesting work. He's not an architect; he's an artist, and we worked with him. And he plays with light, and so we kind of consulted with him to understand how we can have that light in the atrium that's on the 4th floor, skylight that's on the 4th floor, penetrate all the way down 3 floors. And we did a lot of intense analysis to understand the scale, the angle, the spacing, the materiality, and everything for that. And so this was a very cloudy day. Syracuse has a lot of cloudy days. So this was that, and this was late winter, and it was still bringing a lot of light into the space. This was just right after construction, this photograph, hence you don't see any people. But building on the right is the existing building, and we were able to make those connections. 1+1 = 1, and building on the left has offices and conference rooms and that look into the atrium space, and then laboratory space right after. The facade of this building, I think, was really, really interesting, if I may say so. We wanted that modularity, but I wanted a play of this very tectonic facade because the existing building was brick. So we did not want anything that was similar to brick. We wanted something exactly the opposite of that. So one would be to change the materiality and go to a metal panel, which we did. But then we found this panel that actually, it's called, forget what it does. It has an iridescent paint coating on it, and it changes color like a chameleon. So the same panel would look yellow at one time, and from a different angle, it could look deep green or even black. So that was one layer. So we did that. We selected that material. Second thing was, even though it was modular, we modularized the whole thing. So there were 3 different panel sizes. I think it was 12 inches, 1'6", and then 2 feet. And then that was the second layer. And the third layer was we did this in and out, like a couple of inches back and forth. So we had a program in Revit that we ran an algorithm to tell us or generate patterns for us And so we kind of put in all the numbers there and generated this pattern, and then we selected one of the patterns that worked best for us. In this case also, we did a mock-up. We did an intense kind of mock-up of same thing, water test. But this was also because this was the first time we were doing it, and we wanted to understand how all the materials come together. So the people who were building it actually built a mock-up to understand how it comes together, so that when they do the original building, it's much easier for them. And so this is very different from construction that happens in India. So this is inside, then there are these studs that happen, metal studs basically, then drywall, which is a gypsum wall. Then there is a waterproof membrane that goes on top of that. And then on top of that goes insulation, and there are multiple different kinds of insulation. So depending upon what is the R value of the wall, the insulation you put that much amount of insulation on it. And then you have the anchors that capture the metal panel and then the metal panel. But what's interesting is that there is a problem of mold because there is insulation there, and the inside, because the air conditioning is happening, is cold. Like how you get condensation on glass, you can get condensation here. And to avoid that condensation, you have to balance out the right amount of insulation. And there's a test for it called a WUFI test. It's an acronym. I'm sorry, I don't know what it stands for. I've forgotten what it stands for. But essentially, this German person came up with this test that analyzes, if you give it the overall assembly of the wall, it analyzes for you as to, is water going to get condensed and get accumulated there or not. So we did that testing to understand what it was and right size the amount of insulation that was there. And of course, we did all the things that I talked about in Dartmouth, worked with the building systems, and there were no operable windows here because it was a lab building with hazardous gases, so that we were not allowed to do any operable windows. And scientists don't like when the temperature in a lab changes, because they like consistency so that the results that they get are exactly the same and don't change. So this is what we ended up with, this very tectonic facade that kind of, so both of these facades are the same. So it goes from this really deep purple to a light green here. And on top of that, we also added these vertical fins that had these light fixtures added to it. And so those were all the layers that kind of were in line to create this really complex facade. And so that's kind of the color variation that you see from top left to top right. I think it goes even darker. Yeah, this is the other shade of it. So lesson learned here was, I wish I had an opportunity to give more cantilever here, and wish this was 10 more feet or so, and this was cantilevering out, and we could have pushed that in. I still feel I could just punch that in, but this was definitely one of the lessons, to get the proportions and the scale right. So I think that's the last slide. That's where we ended. So that's one of the colors. It's like this dark gray color, and you can see all the layers and kind of all the notes, all the movements in that metal panel as it goes in and out, and the fins and the light fixtures, and kind of all comes together. So this is my last slide. So I'm not saying I've figured it out. No way, I'm far from it. But I think I'm at a point in my professional life where I think it is starting to make a little bit more sense than what it was 20 years back. So I think that's it. I'm going to stop my video sharing.
Yeah. Thank you, Arjun, for such a wonderful presentation.
Oh, well.
Yeah, we'll have some questions from the audience now.
Absolutely.
Okay, there's a question by Sanika Sahasrabudhe. Were there any challenges or problems that you might have faced while constructing a new building next to old one, or as a part of the old building?
Yeah, there are always considerations, but whenever we do a project like that, if we are doing an addition to an old building and we are actually absolutely right next to it or sticking to it, then we do we do foundation analysis, we do soil analysis, we do probes. Basically, we core through the building just to understand, depending on how old or how new the building is, and if you don't have the drawings. And even if you do have the drawings, we generally do multiple cores at multiple locations to understand what the makeup of the building is. But I think a true foundation and soil analysis is the start. Um, we always do that, yes. Does that answer your question?
Yeah. Um, how do we combine vernacular architecture style with the new technologies?
Yeah, that's a difficult one. I don't think I've figured that out yet. I don't think you have to combine it. I think combine is a very strong word. I think you have to learn from it. I think you have to learn from the vernacular that's there and learn lessons. And there are reasons why they did things the way they did it. And if you can accommodate those learnings in your architecture, then it somehow starts to blend in with all the right things that the vernacular was doing in the first place. Um, yeah, I think rather than blending or or trying to copy it, I think learning from it, understanding why things were done the way they were done, and then applying them with all the modern technology that we have, to me, makes more sense.
All right. One more question is, can you share any experiences, challenges you faced while doing or starting with any major project?
Yeah, I think there are two sets of challenges that are there generally for any project, and the challenges get more immense depending on the scale of the project. One is to figure out on the client team side, because we are dealing, most of my clients are in higher education. There is a very clear-cut hierarchy there, and so for example, a typical client team would have somebody from, suppose if it's Pune University, right? So there'll be somebody from the people who deal with the construction, right? Then there might be a sustainability office there. So there might be one person from sustainability. Then there are the people who we are actually designing the building for. Suppose we are doing it for the physics department. There will be the president of the physics department or the dean of the physics department, and three more faculty there. So that's one part of it. Then the president of the university is there, and so we always tell clients to establish a chain of command at their end, so that we know what, if we get three different opinions, it is very difficult to understand what is the right feedback. So that is always challenging on a new project on the client side. And I think most of the projects that we do in our office, we do the integrated approach. And I think not everybody is still willing to open up. And sometimes as the architect, sometimes we are not willing to participate it, because if a mechanical engineer says that make your windows smaller, and I don't want to make them smaller because they don't work for me, I'm like, hey, screw you, I'm not going to do that. But that's not the right attitude, right? It won't work that way. So I think the first project with any new team is always very challenging, but the next project that you do with them with the same team, or it gets a little easier because you know them, you know how they work, they know how you work, and you develop a certain trust. And so that's the challenge I think, on the design side.
There's another question by Amit Nigde. What is it like overriding earlier's architect job to speak his language of design and creating your own signature?
Say that again, repeat that question again, please.
What is it like overriding earlier's architect job
Okay.
to speak his language of design and creating your own signature? I think, Amit, can you elaborate on this? The question is not very clear. Amit Nigre, if you're there, please redefine it again. Okay, we'll take up another question. How do you perceive or treat transitional spaces in your design?
Oh, that's a good question. Oh, transitional spaces are the most fun spaces in our educational and academic buildings. There's an analysis that was done in which they say that 60 or 40% of the learning happens outside the classroom. And I don't think we give enough importance to that. The Jeffrey Baba example that I showed you was not referred to us by anybody. It was just us 5, 6 friends hanging out in the library, pulling out a book and going through it and making sense of it. I think, but that memory is so clear in my mind that we were so fascinated by his architecture. He's from Sri Lanka, that we were like, oh, wow, this is fantastic. And I'm sure if I asked my other friends, they would say exactly the same thing. So those transitional spaces actually have been gaining steadily a lot more importance than classroom spaces. And a transitional space can include everything and anything from a extremely wide corridor having benches and chairs for students to gather, to end of a corridor that has a small table and 4 chairs for you to sit and chit chat with your friends, or maybe extended time for your for your lunch place where you can sit down and have chit chat and have more tea, or more formal spaces where there are study rooms, there are open study rooms, collaboration rooms, student lounges. So we kind of try to balance all that when we do projects. So there are all these terms that we use. See and be seen is one of them, where you learn a lot from your seniors and juniors doing an activity. You are fascinated by it, and so especially in architecture, you can see that, or even in research, somebody's making a model, you definitely will be fascinated if you are able to see that person work on it. So these spaces are extremely important, and they're the most fun to design too.
Yes. There's a question by Sachin Vaman. Hi Arjun, fantastic work. It's good to see that the foundation of your design is based on climate responses and the way you give so much thorough thought on all building facades. My first question is, what is the maximum green rating you achieve for your buildings? And second question is it really tough to convince client when you want to contrast your buildings, which is not exactly in sync with existing building?
So the highest rating we've gone is LEED Platinum, but the Dartmouth project that I showed you it's an EUI of 18. And EUI of 8, basically that's what the energy it's consuming. So it is one of the lowest performing building that's there for that region, or even the East Coast, for the climate that it is in. For a typical building that size with that program would use an EUI of about maybe 75 to 120, and we are using about 18. So I think that's the most high performing building that I've done. It is definitely a challenge to convince your client. If you have to truly do a high performance building, your client has to be on the same page with you on that. Because if the client is not, they will find every reason possible to value engineer things out of it. And trust me, you cannot win the money battle, because all of these high performance buildings come at a premium. And even that extra amount, extra dollar or rupees or whatever it is per square foot is an opportunity to be cut out, because the change that you see, the overall cost and or the operational cost is you see it immediately, but you're paying for it now, right? If you're paying 30 or 100 rupees per square foot more right now, but you're seeing savings right now. But you have to put those two and two together. It might take 30 years for you to recoup that money. So yeah, long story short, your client has to be with you. And your last point about contextual versus not, that's again, that's a very individual thing. I always, my personal opinion is that there are times when you have to stand out with a red jacket, and there are times where you have to blend in with a kurta pajama. So it's your choice. There's a moment for everything, and there is a right place and the right time to do it. So there is no right or wrong answer on that.
Good. This question by Rishikesh Ashtekar. Sketching versus software. What constitutes more on evolution of form of your buildings?
Both. Can't get away with any. You need to know how to sketch and you need to know how to model. It has to be both.
Okay.
That's a very simple answer.
Another question, what was or is your most memorable or favorite project that were the challenge, and what were the challenges faced?
I don't have a favorite project yet. So I don't have it yet. When I have it, I'll let you know. Every project has different challenges. Every project is different. Interesting client, not so interesting client, difficult site, easy site, difficult climate, easier climate, construction market, easy construction market, really, really hot construction market where you have to do everything to save. So it's a combination of everything. So.
This question by Raghu sir, do you consider embodied energy of materials to make your buildings environmentally conscious?
Yes, we absolutely do. And that's the big push now. Where it's not just embodied, it's operational also, right? So you have to look at both. Embodied is all the materials that go into the building and what's the carbon value for it, versus operational, how much carbon are you actually needing to run it. Yes, we do a thorough analysis of that. We also do a life cycle analysis, which to me is a little bit more difficult because there are not a lot of materials with accurate numbers. So you have to basically take a generic carpet or a generic marble tile or a generic, electrical wire. So the market is still evolving. It's not there yet, but yeah, yes. To answer your question, we do both those analysis and the life cycle analysis too.
Okay. So any advice as an alumni to our students, MNCS students?
Read books. Don't look at pictures only, read books. I think that's definitely important. I think we have a habit of, and that's just not only MMCA, it's just, we like to only see pretty pictures. I think reading is important. Asking yourself why, how, and what. I did that at a much later stage in my life. I think ask those questions to yourself and take a pause. I think that's really, really, really important.
Great. That was wonderful question answer session, and thank you so much. As we end this series today, Finally, I would like to take this opportunity to place on record our hearty thanks to all speakers for delivering to us such remarkably outstanding presentations. It was beyond excellence. Well, the true measure of an institution's value is in the achievements of its alumni body. The distinguished lineup of successful, sensitive, and dynamic designers that we had as a part of this webinar series was indeed a matter of great pride for us at MMCOA. In academics, we often question ourselves, what does teaching architecture come down to? Well, in the Zaha Hadid's word, I don't think you can teach architecture, you can only inspire people. So here we had some of the best of our alumni to speak to all of us, to ignite a passion, and most certainly give us an impetus to striving to achieve our own person best. For all our participants, I can only say one thing. Learning never ends, and so this series has definitely been engaging and stimulating for each one of us. I thank you, Arjun, for such a wonderful presentation, and I thank all the speakers who have been part of this webinar series. Thank you. I would request our principal, Dr. Ujjwala Parsude ma'am, to please address the vote of thanks.
Good evening. Am I audible?
Yes, ma'am.
Yeah. Good evening, Architect Arjun. It was very interesting session. Thank you for sharing your projects, your experiences to our students. I'm sure your approach in finding your own method of design, thinking, the nuances of your projects, learning moments that you have experienced over a period of time would definitely encourage our students to explore more. I thank you all for sharing these moments of your experiences with our students and faculty so candidly. I thank all our alumni speakers for sharing your experiences with our students. And hereby, with this series, I would also like to share that this is one of the events that we have planned to connect with our alumni. I personally believe that our alumni is our biggest strength. And with this series, I would also like to announce that we are planning to come up with a publication which will have our alumni's work and profile, which will be available for all the alumni and all the students of MMCOA. I appeal all the alumni to please share your data with the college so that we can expedite this process and come up with this publication as soon as possible. I thank all the alumni speakers, our audience, all the faculty members, students, practicing architects, and even our non-teaching staff who have attended this session and who have been with us for last 8 days. I thank our team of International Webinar who has been consistently working to make this event very successful. I thank Marathwada Mitra Manda's honorable management for their support. And thank you, Architect Arjun, again for taking time from your busy schedule and making yourself available for this session today. And I wish you all the best for your future endeavors. Thank you very much. Thank you, everyone.
Thank you so much. This was really a lot of fun. Thanks for having me.
And also, I take this opportunity to welcome you all whenever you are here in Pune to MMCOA. Make sure that you visit our college. We would be honored to welcome you.
Absolutely.
Thank you.
Thank you.
Thank you so much. And also we have published a small booklet of all the speakers who were there for this event webinar series. So it's a brief note about them is written, and it's just a small booklet for us as a memory. Thank you. Thank you so much.
Yeah.
Thank you.